I'm Hugo Spowers. I'm the founder and managing director of Riversimple, and we're here on the Isle of Wight for the REPOXYBLE project. At Riversimple, we're developing hydrogen fuel cell cars and the business case for bringing them to production. And our role in the REPOXYBLE project is to present the end user case for totally recyclable composites. Our business model as a car manufacturer is to never sell a car, believe it or not. We will only ever sell service contracts. And typically a customer will take a car for 3 years as if they're leasing a car. But instead of just paying a monthly payment for the use of the car, for having the access to the car, they also pay a mileage rate. But that covers all their costs. It includes fuel, insurance, things like that. But most importantly, the fuel. The other difference from a lease is at the end of the 3-year contract, the car comes back to us, but we don't sell it into the second-hand trade. We provide a second, a third, a fourth-hand customer. So we design the car to stay on our balance sheet from a clean sheet of paper when we're designing it, right through to end of life. And it means that our interest, instead of obsolescence, is longevity. The longer the revenue stream, the more money we make, because all that revenue comes to us. So we design for long life, we design for maximum efficiency, maximum recovery of value at end of life, because all these things reduce the lifetime cost. And the price to the customer is not driven by the build cost of the car, because we're not selling it. It's driven by the lifetime cost of the car. The great thing about that business model when it comes to composites is that even though composites are and always will be more expensive than steel, it allows you to build a lighter car that's more efficient and will save more money on the fuel over the life of the car than the premium we pay for the composites. So we're quite clear that we can come to market at an equivalent cost of ownership to the customer of a conventional steel car long before it's as cheap for us to build as a conventional steel car. The other great advantage for us of composites is that the minimum scale of production is much, much smaller, about 100 times smaller than making steel cars. If you make steel cars, a pressed steel tool costs about $1 billion, but it does spit out about 300,000 cars a year. So that's how many you need to make before your economies of scale bottom out. In the case of composites, it's only about 5,000 cars a year. So we can come to market at a much smaller scale and still be profitable. We don't have to ramp up to 300,000 to break even. It also means that we can make different models for different niches, for different countries, for different cultures, for different environments. We're not driven by the platform economics of pressed steel cars, where they try and make a car that's suitable for worldwide production. We can make different cars for different people in different places. I think recyclable composites is one of the most critical elements for us in the future. I don't believe we can ever have a sustainable industrial system that is dependent on continuous consumption of finite resources. We have to find a way of completely closing the loop, having a steady state economy ultimately that relies on material stock that is on our collective balance sheet rather than continuing to mine or extract non-renewable resources. So the big advantage of composites, as I said, lightweight, energy efficiency, lower life cycle, lifetime cost, a smaller minimum scales of production, all those sorts of things. The one big problem for us is recyclability. And recyclability for us is much more important and much more valuable than it is for a conventional manufacturer. Because we know when we design the car at the beginning, it's going to be ours at end of life. So we design it for maximum recovery of value coming back to us. And that's not just raw materials, by the way, it's also components that can be refurbished. At the moment, truly recycled composites are not available. We did a study, or had a study done for us over 10 years ago now, before we committed to using composites. looking into whether it was possible to develop these materials. We know it is. We know they won't be available when we first come to production, but to commit to composite vehicle production, we needed to know that there was an end game in sight where we could incrementally incorporate new and completely recyclable materials into our production manufacturing model. So the REPOXYBLE project is tackling the single most intractable part of the recyclability of our cars. And so we're absolutely delighted to be involved in it. Yes, so our manufacturing facility, which we have a design for now, is able to produce about 5,000 cars a year, which we believe is the optimal scale of production of composite vehicles. And unlike a normal manufacturing facility, it has two production lines, one of which is an assembly line, and one of which is a disassembly line, because when we reach a steady state of vehicles in the market that we're supporting from that one plant, we will have as many cars coming back each day as are going out each day. And each one of those cars that comes back has got to be disassembled. So the manufacturing facility, like a conventional car plant really, the only bit that's made on site is the composite structure. And all the other components are brought in and to the assembly line to be assembled onto the car, because this is the one big item that you don't want to be transporting around the countryside. Composites also offer a whole raft of other potential benefits. They're much more versatile than metal, which is all homogeneous. It's the same in every direction, whatever you do with it. With composites, we have the possibility of designing a much more integrated vehicle that makes a lot of the other components that you'd normally have in a car redundant. You can eliminate them. Nothing is cheaper or lighter than a component that isn't there. And with a composite structure, you can design a car that's got fewer components, is inherently lighter, so it is a compounding impact on benefit on top of the inherently lightweight of a composite structure anyway. But also, because it's a composite, it's actually quite a complex material, multi-function. You can tailor the performance of the structure in accidents much better to absorb more energy with a lighter weight structure, and there's less energy to absorb because of the lighter weight structure. So it's much better from crash worthiness point of view. And finally, with the possibility that's emerging in REPOXYBLE of embedded circuits, there's all sorts of possibilities there that we're looking at. One of them being, for instance, being able to analyze the structure post-accident because it's very difficult non-destructively to test the status of a structure after it's been through an accident. With metal, it's quite obvious because it's buckled. But with composites, you can have hidden damage that isn't visible, and there's the possibility of being able to analyze it with embedded circuits that are already structured in the structure from the manufacturing stage. We're a small company, and our real strength is in systems integration. We don't develop any fundamental science. We don't have the capabilities to do that. We're just putting existing technologies and new technologies together in a different pattern of relationships. And that system level innovation, we believe is generally underestimated how powerful it is. However, we do need these new technologies, and we depend entirely on our relation. We have relationships with lots of universities, and REPOXYBLE is a great example of a project where we're working with a number of different research organisations to develop the technologies that we know we're going to need in a few years' time. So we're a Riversimple movement. Follow us. Thank you.